Hello and welcome to another NGen Math 8 lesson by eMath Instruction. My name is Kirk Weiler, and today we're going to be doing Unit 7, Lesson 3 on simplifying fractions. Simplifying fractions, something that you've been doing almost from the time you first learned about fractions. And yet today we're going to look at it in a slightly different way. Now, I really urge you, as we look at this today, to try to kind of put aside how you've simplified fractions in the past. And the way you've simplified fractions in the past, let's be honest, is you've looked at a fraction, you've looked at the numerator and the denominator, you've probably said to yourself, what's the biggest number I can divide into both of these? And then you've divided both of those numbers by that largest divisor, okay? We're going to be working with that a bit today, but then we're going to be looking at how you can think about simplifying fractions in a slightly different way. So let's get into it right away. Now, you've been writing fractions in their simplest forms for years, and we want to understand this from the most basic building blocks. So, let's take a look at an exceptionally easy exercise, exercise number 1. Simplify each of the following fractions. All right, now, before you even simplify these, I want you to also remember that a fraction represents division, right? It represents dividing the numerator by the denominator. So really, when I look at 10/10ths, right, that is the same as 10 divided by 10. And 17/17ths is 17 divided by 17. And -13 -13ths, whatever that means, is -13 divided by -13, and likewise for n over n. All right, so what I'd like you to do is simplify each one of those. All right, well, I'm really hoping you found these pretty easy, right? Because 10/10ths is the number 1. And 17/7ths is the number 1. And -13 divided by -13 is the number 1. And n divided by n is the number 1. All right? All those are equal to the number 1 by definition. Literally, right? 10/10ths is 1. 17/17ths is 1. And although it might be harder to think about these two, right, we can really think about them in terms of division. -13 divided by -13 must be 1 because -13 equals 1 times -13. Now we can summarize all of this in a very, very easy statement, exercise number 2. Summarize the principle of exercise number 1 below. And let's do it together. Any fraction whose numerator and denominator are the same is equal to 1. Any number divided by itself, except for the number 0, is 1. By the way, 0 divided by 0 is a very strange thing, and we're not going to get into it right now. But any other number divided by itself, -13 divided by -13, 10 divided by 10, n divided by n, as long as that number is not equal to 0, it's equal to 1. Okay, now let's use this to help us simplify fractions. Here we go. We can use the property we saw in exercise number 2, namely that any number divided by itself equals 1, to simplify any fraction. And let's see how we can do that in exercise number 3. Consider the fraction 12/20ths. Letter A, what is the greatest divisor of both 12 and 20? All right, well, this is simple, right? Think about 12 and 20. What is the largest number that divides into both of them? Pause the video now and write that down. All right, well, that's the number 4. 4 is the biggest number that divides into both 12 and 20. Now, letter B. Write the numerator and denominator of 12/20ths as a product involving the answer to A. Okay, so in other words, I can say that 12/20ths is exactly the same as 4 times 3 divided by 4 times 5. Okay, and of course that's true, because 4 times 3 is 12 and 4 times 5 is 20. Now, before we move on, I just want to point something out that's really cool about fractions, right? If I had two fractions like 2/3 times 7/5, right? The way that I multiply two fractions is I multiply their tops, let me just move this 4 out of the way, and I multiply their bottoms, right? That's how I multiply fractions, and you've been seeing that for quite some time. But I can take actually a fraction where the numerator and denominator are written as products, and I can, if you will, undo it. I can actually write it as the product of two fractions. So, letter C, Rewrite the product in B as the product of two fractions, one of which has an equal numerator and denominator. All right, so I could actually rewrite 12/20 in many different ways. But one way I could rewrite it is 4/4 times 3/5. Right? That is one way I could rewrite it. I could also rewrite it as 4/5 times 3/4. I could rewrite it as 4/20 times 3. There's a lot of different ways I could rewrite it, but I can definitely rewrite it this way. Now let's take a look at letter D. Simplify the product in C. You see, I can now simplify this, right? Because 4 divided by 4 is equal to 1, and 1 times any number is just that number. And that is the simplified version, right, of 12/20. 12/20 and 3/5 are the same. And they're the same because I have literally found that factor of 4 in both the numerator and denominator, and I have then taken that and rewritten it as the product of two fractions, one of which is equal to the number 1. And anytime you take 1 times a number, you just get that number. Now, I get it, by the way, I get it. If you were asked to simplify the fraction 12/20 and you just said, look, the quick way to do that is to divide the top by 4, divide the bottom by 4, and I'll get 3/5, I get it. And I certainly think you should continue to do that from here on out. But this is going to lead us to something more important algebraically. So we're going to do this during this particular lesson. Let's keep going. All right? Maybe keep going. There we go. All right. Exercise number 4. Use the technique from exercise number 3 to simplify each of the following fractions. All right, so let's do letter A together. I've got 6/21, right? What is the biggest number that divides into both 6 and 21? Well, it's the number 3, right? So I could write the numerator as 3 times 2, and I could write the denominator as 3 times 7. Okay? Now, because I've done that, I can now break this up into the product of two fractions, specifically 3 divided by 3 times 2 divided by 7. But the beautiful thing is, what we saw in exercise 1 and 2 is that 3 divided by 3 is just the number 1. And 1 times 2/7 is just the fraction 2/7, right? And that's how I want to simplify fractions, at least in today's lesson. Why don't you try to do the same for the fraction 30/18? All right, well, the biggest number that divides into both 30 and 18 is 6, right? So the numerator I can write as 6 times 5. The denominator I can write as 6 times 3. So then I can break that into 6/6 times 5/3. 6/6 is equal to the number 1, and therefore that fraction simplifies into 5/3, right? It's really that easy, and that is really why fractions simplify the way they do. They simplify the way they do based on the product property of fractions and the fact that any number divided by itself is simply equal to 1. Let's do this a bit more before we move back into exponents, because where did exponents go? I mean, I thought this whole unit was about exponents. We'll see them eventually. But let's take a look at exercise number 5. Simplify each fraction by using the greatest common factor, divisor, of the numerator and denominator as we did in exercise number 4. So the last time I had this like all really structured, right? This time, not as much. All right, so let's do one of them together and then have you do the other ones on your own. So I've got 32/40, right? The biggest number that divides into both 32 and 40 is 8. So I can rewrite the numerator as 8 times 4, and I can rewrite the denominator as 8 times 5. Okay? I can now rewrite this as 8 divided by 8 times 4 divided by 5, but 8 divided by 8 is equal to 1, and 1 times 4/5 is just 4/5. Now, I'd like to actually also do letter B together, because letter B and letter D can be a little bit tricky, okay? So let's talk about letter B, and then we'll have you do C and D on your own. Letter B is 5/20, right? Now, if I think about the largest number that divides into both 5 and 20, that number is 5. All right, simple enough. So how do I rewrite the numerator, right? Given that, 5 is the largest number that goes into both, I'm going to rewrite the numerator as 5 times 1, and I'm going to rewrite the denominator as 5 times 4. All right, but I really do need that 1 sitting there. Otherwise, things can get a little confusing, right? Especially because I really want the product of two fractions. And now the product of those two fractions is 5 divided by 5 times 1 divided by 4, but that's just 1 times 1/4, and that is 1/4. All right, simple enough. Why don't you go ahead and do C and D? All right, well, the largest number that goes into both 54 and 12 happens to be 6. Okay, so the numerator can be written as 6 times 9, and the denominator can be written as 6 times 2. Then that can be written as 6/6 times 9/2, and that's 1 times 9/2, which is just 9/2. You don't have to change that to a mixed number unless the directions specify. I'm just going to leave it at 9/2. 8/24 is very similar to 5/20. The largest number that goes into both 8 and 24 happens to be 8. So I'm going to rewrite this numerator as 8 times 1, and I'm going to rewrite the denominator as 8 times 3. Always make sure that you've got a product in both, right? So then I'm going to have 8 times 8 times 1/3, and that's just going to be 1/3, right? Because that is equal to 1. And that's it. Again, I can understand if you're resistant to this. If you're saying to yourself, look, man, it only takes me one step to go from here to here. I just need to know to divide both of these by 8. I get it. But now we're going to move into a connection between this and exponents. So let's get to that. It's taken us long enough. We can understand one last exponent rule by using what we've seen in the last few exercises. Let's take a look at exercise number 6. Consider the expression 2 to the 5th divided by 2 to the 2nd. All right, I'm going to write this a bit bigger right here. 2 to the 5th divided by 2 to the 2nd. Okay. Now, letter A just says evaluate both the numerator and the denominator. So I actually want to know what they're equal to. All right. So the numerator is 2 to the 5th, which is 2 times 2, that's 4, times 2 is 8, times 2 is 16, and times 2, there we go, is 32, right? That's 32. And 2 to the 2nd is 4. Okay, that's simple enough. Letter B, simplify the fraction using your answers from A. It will be a whole number. Right, so this is easy because 2 to the 5th divided by 2 to the 2nd equals 32 divided by 4. And I'm not going to do what I did before because that's just 32 divided by 4 is equal to 8. Awesome, right? But now let's get into the exponents. Now remember, we had that exponent property that said when you multiply two things that have the same base, you add their exponents. Well, we can manipulate that a little bit in letter C. Use the product law of exponents to fill in the following. 2 to the 5th equals 2 to the 2nd times what? And again, I'll write this a bit bigger so you can see it a little bit easier on the screen. 2 to the 5th equals 2 to the 2nd times what? Well, what should I have sitting in here given that when I multiply two things that have the same base, the exponents add? Pause the video now and think about this for a moment. Well, it should be 2 to the 3rd, right? Exponents add. So 2 to the 2nd times 2 to the 3rd is 2 to the 2 plus 3, which is 5. Simple as that. Now let's look at simplifying this the way we did those other fractions. I've got 2 to the 5th divided by 2 to the 3rd, right? Or 2 to the 2nd, my apologies. So what can I do? Well, I can write that numerator as 2 to the 2nd times 2 to the 3rd, and the denominator I'm going to write as 2 to the 2nd times 1. I can always throw a times 1 in anywhere I want. Now notice, in both the numerator and denominator, I have a 2 to the 2nd. So I can now write this, I can now write this as 2 to the 2nd divided by 2 to the 2nd times 2 to the 3rd divided by 1. And of course, what is 2 to the 2nd divided by 2 to the 2nd? It's equal to 1. Anything divided by itself is equal. I don't care if you got cow divided by cow. That's equal to 1 because one cow can fit into one cow. That doesn't make a lot of sense, but you know what I mean. I don't care what's in the numerator and denominator, as long as it's not equal to 0. If you have the same thing in the numerator as in the denominator, it's equal to the number 1. So that's just 1 times 2 to the third, which is 2 to the third. Now, I realize up here, we got as our answer 8. And down here, we got as our answer 2 to the third. But if you think about what 2 to the third is, 2 times 2 times 2, well, 2 times 2 is 4, times another 2 is 8. Now, take a look at something, right? When I multiply two things together that have the same base, I add their exponents, right? Here, I divided two things that had the same base, 2 to the fifth divided by 2 to the second, and I got 2 to the third. It's like I got 5 minus 2 as my exponent. And that is totally the case, right? So when you multiply two things with the same base, you add their exponents. And when you divide two things of the same base, you subtract their exponents. Now we're going to work with that exponent rule a lot more in the next lesson, so don't worry too much about that. For the rest of this lesson, we want to continue to work with what we just did, okay, with this sort of factoring idea. So notice that when we divide two expressions with the same base, the exponents subtract instead of how they add when we multiply. So let's take a look at exercise number 7. Simplify each of the following expressions by factoring either the numerator or denominator and then canceling in quotes, math teachers hate that term, canceling any fraction that's equal to 1. All right, so let's take a look at the first one. I'm going to write it a little bit bigger. 3 to the 9th divided by 3 to the 2nd. Okay, so, how do I want to think about this? Well, notice that the smaller power is on the denominator, 3 to the 2nd versus 3 to the 9th. That means that I could rewrite the numerator as 3 to the 7th times 3 to the 2nd, and then in the denominator I might have 1 times 3 to the 2nd. Now, just like before, I could break this up into the product of the two fractions, but the whole point is that these two, when they divide out, are equal to 1, and that just leaves me with 3 to the 7th divided by 1, which is simply 3 to the 7th. And we're not going to evaluate that. We're just going to leave it as 3 to the 7th. Okay. Now, by the way, if you're wondering at all why I did change 3 to the 7th over 1 into 3 to the 7th, keep in mind that when I divide by the number 1, just like when I multiply by the number 1, it doesn't change anything. Okay? That's when the 1's in the denominator. But let's look at one where the higher power's in the denominator and the smaller power's in the numerator. So again, writing this a little bit bigger, I've got 10 to the 2nd divided by 10 to the 5th. Okay? So the way that I want to simplify that is I want to think about in the numerator, I've got 10 to the 2nd, we'll do times 1. And then the denominator, I'll have 10 to the 2nd times 10 to the 3rd. Now, the 10 to the 2nds, those are the ones that cancel. And they don't really cancel, it's just that 10 to the 2nd divided by 10 to the 2nd is equal to 1. And then I'd have 1 times what remains. So these two, if you will, equal 1. And what I then have is 1 divided by 10 to the 3rd. Okay? And it's pretty easy, right? The exponents still subtract. 5 minus 2 is 3. It's just happening that because the higher power is in the denominator, I'm left with the exponential expression in the denominator. In this one, the higher power was in the numerator, so I was left with the exponential expression in the numerator. All right, I'd like you to play around with the last two, all right, which have variables instead of numbers. Pause the video now and see what you get. All right, let's take a look at letter C. Letter C, I've got x to the 8th divided by x to the 2nd, right? The higher power is in the numerator. I want to cancel that denominator. So I'm going to rewrite the numerator as x to the 2nd times x to the 6th divided by x to the 2nd times 1. Okay? Again, x to the 2nd divided by x to the 2nd cancel. They're equal to 1, which leaves me with x to the 6th divided by 1, and that's just x to the 6th. No need to leave that 1 in the denominator. Is it wrong if you do? No. But if I asked you how many friends you had over and you told me 7 firsts instead of 7, It'd be a little strange, right? 7 firsts, what does that mean? Just as weird. So x to the 6th divided by 1 is just x to the 6th. But in this case, right, which is maybe the trickier case, we have y to the 5th divided by y to the 6th, right? In the numerator, I'm going to have y to the 5th times 1. In the denominator, I'm going to have y to the 5th just times y to the 1st, right? These two y to the 5ths are now going to cancel, right, to equal 1. That's going to leave me with 1 divided by y to the 1st, or just 1 divided by y. And again, if you're bothered by the fact that I didn't just somehow make the 1 magically disappear, keep in mind that if y was equal to 2, if y actually had a value, let's say y was equal to 2, then the answer to this problem is 1/2. It's not 2. On the other hand, over here, right, where I have x to the 6th divided by 1, if x was equal to 2, let's say, x to the 6th is equal to 64, well then I'd have 64 divided by 1, which would be 64. Wouldn't be 1/64, right? So when you have a 1 in the denominator, it's okay to get rid of it. If you have a 1 in the numerator, keep it there, because 1/2 and 2 simply aren't the same number. Now we're going to work with this exponent property more as we move on, but let's wrap this one up. All right, so today, right, we really looked at how to simplify fractions in a totally different way than you probably ever had, right? And how did we simplify them? We looked at the numerator and denominator, and we thought about the largest factor, or divisor, that's the same thing, of both. And then we broke up the numerator and denominator into products, and then separated those products into the product of two fractions, one of which was equal to 1. The other was equal to our simplified fraction. We then saw how we could use this to come up with a new exponent property, basically saying that if I have the same base in both the numerator and denominator, if I'm dividing two exponential expressions with the same base, I then subtract the exponents instead of adding them. All right, and as I said, we'll get more work with those in future lessons. For now, I just want to thank you for joining me for another NGen Math 8 lesson by eMath Instruction. My name is Kirk Weiler, and until next time, keep thinking and keep solving problems.